Okay, folks, we're going to talk about how to do a confidence interval for a t-test with independent samples. But before we do, one last piece, the effect size. We're still using the idea of Cohen's d, but it's estimated Cohen's d. This looks relatively familiar. What is the mean difference, m1 minus m2, where before, when we did the one sample t-test, we had the estimated standard deviation. Now we just use a pooled variance to find that. Remember, from variance to standard deviation, we take the square root of variance to get standard deviation. We're taking the square root of pooled variance, so estimated standard deviation. Again, the whole idea here is that it's independent of sample size. Okay, let's set that aside and go on to our confidence interval. The way this works, we're focused on this piece and we're solving for the population difference. Okay, so this one's a bit different. We are going to compare the sample means and then do plus or minus the t critical multiplied by the estimated standard error. Okay, so we're going to work out this example in a second, but let's say we have a sample mean of 88 and a sample mean 2 of 83. Say our DF is 18, and we want to make a 95% confidence interval, and we don't have an idea of direction. We find our t critical, we find our estimated standard error, and we do some math. So let's go to the next slide where we've worked some of that math out. Okay, DF is 18. What did I say? It's a 95% confidence interval, so it's alpha 0.05. So our t critical is going to be 2.101. Okay. Let's say that I give you the pooled estimated standard error of 1.3. And the next one we're going to work out from an earlier point. We would do 88 minus 83 plus or minus the product of the t critical 2.101 multiplied by the pooled estimated standard error of 1.3. You multiply those, 2.73. Subtract 5. 5 plus or minus negative 2.73 gives us 2.27 comma 7.73. You're like, what? What do these numbers mean? This is basically what is our confidence level for that difference. If you think back to the null u1 minus u2 equals 0, that's what we're comparing this to. So we're comparing these values to 0. So we're 95% confident the mean difference between the two classes is between 2.3 and 7.7. And the question we ask ourselves is 0 contained? Because 0 was the null. And since 0 is not contained, we would reject the null hypothesis. Okay, let's keep going. You'll see that same concept again, I promise. Okay, let's go back. This time we're going back to that data we used within the last video with the classes. We had 2 GPS professors. The mean difference was not very high. We worked out the math. We got a t-test of like negative 0.2, which is basically nothing. And we said we failed to reject. So let's do that from the confidence interval way and see if we get the same answer. Okay, same t critical, same estimated standard error. We multiply t critical times estimated standard error, get 9.83. Find this difference to be negative 0.92. We do the math, negative 10.75 to 8.91. Anything different? Yeah, of course. 0 is contained between these two values. We failed to reject when we did it as a t-test. We failed to reject here because 0 is contained. Okay, so this confidence interval is just a different way to approach these t-tests. Let's do one more example. Okay, and here's that same sort of concept with the 0. If the null is u1 minus u2 equals 0, if the null is true, we need 0 to be contained. 0 is contained within the one we just did. In this image down here, 0 is not contained. So before, when 0 is contained, we fail to reject. Same way we did before with that tiny little t-test of negative 0.2. Down here, 0 is not contained. We reject the null. Okay. Here's our example. And this one you can see worked out over here on the right. Gina wants to compare two groups of students, one that lives on campus and one that lives off campus. Ironic, since right now we all live off campus. She's not sure what difference she's going to find, but she used an alpha of 0.01, and she has some data. Okay, so she has 6 people she pulled on campus, 4 people she pulled off campus. She has their mean GPA, and then we calculated the sum of squares to help her out. So what we need to find is a t-critical. We need to find, I've given you some squares, we need to find pooled variance, then estimate standard error. And we're not finding the t-statistic, but we're going to work it out the other way, the confidence interval. Okay, so if you look over here to the right, I've recreated everything same as on the left. I have the formula, M1 minus M2 plus or minus t-critical times estimated standard error. We have our data. Our t-critical is a DF of 8. It's two-tailed, and alpha is 0.01. So our t-critical, if I did this correctly, is 3.355. Okay, so we have that. We could plug that in if we needed to. But we also know that we need to get to estimated standard error. To do that, we got to find pooled variance because we're given some squares. So pooled variance, 0.58 plus 0.25, those sum of squares, over the DFs of 5 and 3. So we work that math. We get 0.104 pooled variance. Now we find estimated standard error, all under the square root. 0.104 divided by 6 plus 0.104 divided by 4. Again, using N, not DF. All under the square root. 0.017 plus 0.026. We add that up. We do the square root. We get 0.207. Whoops, I scrolled. Okay. So let's plug that in. We get t-critical, 3.355. Estimated standard error, 0.207. Mean difference, 3.15 minus 3.1 plus or minus the product of those. That gives us 0.05 plus or minus the product of these two is 0.694. It's not looking good. We do our math, our 95% confidence interval. Negative 0.644, comma, 0.744. Is 0 contained? Yes. So we say since 0 is contained between the 99% confidence interval of negative 0.644 to 0.744, we would fail to reject the null. Okay, we could do the same way with our t-test. We could do, I don't have it written down, but let me pull out my handy dandy calculator. 3.15 minus 3.1 gives us 0.05, and then we divide that by the estimated standard error, which is 0.207. Yeah. Oof. Our t-test result is 0.24. Again, that's 0.24. That matches the fact that 0 is contained. Either way, we do it as a t-test or a confidence interval. We fail to reject the null. 0 is contained. We fail to reject the null. Okay? Confidence intervals. Let me know if you have questions.